This is a very short talk, a 10-minute talk, so I'm going to go. My name is Yuvi. I'm the tech lead and co-founder at 282C, which is a nonprofit that runs Jupyter Hubs and contributes upstream. This is also on behalf of Tarashish from Development Seed, who could not be here. We're going to talk about home directories on the cloud with jupyterhub-home-nfs, which is a new project that we've been using for roughly 9 months or so now. So why use home directories? Ultimately, this is what your users are most familiar with. If you use a Jupyter Hub, and you see the files on the left, they're all on your home directory. If you use an open call, or you're downloading something because a tutorial said you should do that, that all goes into your home directory. It's what survives when you stop your server and then come back a week later. It's a POSIX file system, so you can use tools like Git. They all require POSIX file systems. So while under some circumstances, particularly if you're in like a really corporate environment where you can tell your analysts, well, you have to stop using it or you don't have a job, people definitely need home directories still, unfortunately. So the current common solutions when using this in the cloud is you can use a managed shared file store. Like on GCP, it's file store, AWS EFS. It's great because you don't have to manage a server. All users share the same storage, so you can handle over-provisioning. We'll talk more about that later. And then multiple servers for a user, so you have a GPU server and a CPU server. They can use the same file system at the same time. And the major disadvantage is that there's no way to do per user limits. So one user can use up all of the space because they were following a tutorial that told them to download 2 terabytes of NetCDF files on their home directory. And that will either cause an outage on Google Cloud on Azure, because there you can limit the overall consumption, or on AWS, it just gives you a huge bill because cloud is pay for what you use. But that also means if you use something, you must pay for it, whether you wanted to use it or not. The other alternative is a single disk per user. This is what Zero to Jupyter Hub gives you by default. Each user has their own disk. So one user cannot screw up things for everyone else. But it is just so much more expensive. Because as we'll talk about later, most users don't use a lot of their disk, and some users use up all the disk. And in this case, you're going to pay for, say, 10 gigs of disk for every user, and most users will only use like 500 megs. And so for storage, you're paying for it all the time, regardless of if it's being used or not. Computes can scale up and down. So this ends up costing you like a lot of money. This is the other option, which is to have no persistent home directories. Your finance department will like you. Your users will hate you. So not an option for a lot of people. So again, the biggest problem here is that a single user can blow up your cost. And if you're using AWS as an example, 99 users using 10 gigs each is $297 a month. But one user using 2 terabytes, and most often that is accidental. And I think in almost all of our hubs, we've seen a version of this happen. And we run like 100+ hubs for different groups. Like a single user using 2 terabytes is $600. And often that's like an intern or someone new just following a tutorial and not actually realizing what was going on until, like 2 months later when someone figures out a bill, digs in, and then they get an angry email. And then they're like, whoa, I don't like this cloud thing. It gives me surprises. I'm going to go away, actually. Nobody gets me angry emails if I do things on my laptop. So this is a graph from one of the communities we support, OpenScapes. We currently have them on a 100 gig limit. And you can see, it's a histogram of home directory sizes. And you can see most users use very little, right? And so this sort of inverse power law is very, very, very common across these sort of Jupyter hubs. And home-nfs is designed to give us guardrails to support this use case, while also making it really easy for admins to have predictable cost behavior. So we have 1 disk per hub instead of one disk per user. So this lets us limit the total cost per hub to like a known number that's like almost often pretty small. And it allows us to over-provision. So let me talk about over-provisioning, right? So this is bad math equation, but really the provision size, which is the size you pay for, is how much storage you want your users to have, multiplied by number of users, multiplied by overcommit ratio, which is the number you can tune as, like an admin with knowledge. So let's use an example here. So let's say I want my users to have 20 gigs per user, and I expect to have 100 users, and my overcommit ratio is 0.5. So that means that at worst case, I expect 50% of my users to use their entire 20 gig limit. Right? If you saw the graph earlier, most people don't use anything like that at all. So 50% is actually a pretty aggressive number. And if we do all of that, you can see that we will get a 1,000 gig disk, which is only $80 a month. So if we compare that, so with the 50% overcommit, sorry, it says overprovision. It's an overcommit ratio. It's $80 a month. Even if we do no overcommit at all, it's only $160 a month, while the default EFS with users using 10 gigs, not a 20 gig limit, but using 10 gigs, so that's less than that, is already $300 a month, while the most common use case from our experience is 99 users using 10 gigs and 1 user using 2 terabytes is $900-something a month, right? So this is where the guardrails really come into effect, right? Like the feature we've identified is that per user limits are really important. And once we have those, like a lot of cost stuff comes into picture and like works out better. And that's much better than really going after users with a bat, right? Like that just makes them too scared to use the cloud. And we really want to instead be like, hey, like this is how like you can guide them towards a pathway that works better for them. And like we are also just using, I'm not going to go into the implementation details, but it's all classic Linux stuff, just tuned out to work on Kubernetes and in the cloud very well. This is an example config. Each user gets 10 gigs as a limit, and some people, you can do overrides, so individuals can get more space for whatever reason that they want. And when a user uses up the quota, they cannot create new files, and they cannot modify existing files to be larger. And ideally, their server just starts, and then they can delete files so that they have more space, right? Like there is additional work happening here because in some images still, when you start a server, it's trying to write to the home directory before it'll start, and then if it's full, that'll fail. So there is resiliency work to be done here to allow servers to start when the disk is full. But the ideal user experience for the user is their server starts, they try to save a file, it's like, hey, you're out of disk space, and then they go clean up. Or they go complain to their admin, who either then gives them more limits, or it becomes a teachable moment, right? Like I feel like teachable moments are really important, and this becomes a teachable moment where they can learn about object storage and the fact that it has many advantages over PostGIS file systems, or just using /TMP or something like that. So the disadvantage is that now you run an NFS server, and that is categorically a curse. There is no question about that, but I think it is better to be cursed as a sysadmin because you have chosen this job, you're cursed no matter what, than to be cursed and also have users who hate you. So this is the correct trade-off, I think, given that we are already cursed. And then second is you actually have to put in the effort to teach your users how to use object storage, how to use scratch space, how to think about this in a way that makes sense to them. Because if you don't teach them, they will do what the internet tells them to do, and that is going to be to download things into your home directory and blow up your cloud bill. So these are some of the next things we're working on, which is different quotas per group. So different groups can have different requirements, and like the underlying disk could be automatically resized, so we can guarantee there'll be no outages, even if the disk is full, because the disk will never be full. And then we're also working on alerts for admins when users are getting closer to their limits, so that you can go talk to them and be like, hey, what are you doing? Instead of like doing it after their stuff is broken. Thank you to the NASA Marshall Space Flight Center's ODSI group and the Data Systems Evolution team. They helped fund a lot of this work, and we did a lot of that along with Development Seed. This wouldn't have been possible without like co-creation with them. And you can go test it out. There are instructions there, but it's a pretty new project. Even though I feel like we have maybe 10,000 users on it right now, so it feels reasonably well tested, but it's still new. So it's reasonably cloud agnostic. I'd love for you to test it out and open issues, or reach out to us to see if you have any issues. Thank you. There's only one mic.
Hello?
Yes.
There we go. Cool. There is a fourth option at least the big providers. You can get NetApp cloud volumes at GCP, and NetApp provides ONTAP for both, which I haven't used, at both Azure and AWS, and that supports plain old NFS user quotas out of the box. At least at Google, it isn't particularly more expensive than file store, though less performant. So that, our trade-off was we would rather do that than run our own NFS server. So, it's an option. It may not be the right one for you.
Yeah, so this was a comment about NetApp, which also is a similar setup that you can get on some cloud providers, but it does user quotas, and most common Jupyter hubs, because they're on Kubernetes, do not have different Linux users for each user, so you end up needing project quotas. So that's why we had to create that.
We do. Come to my talk tomorrow.
Yeah.
I think it's an elegant solution.
Yeah, so the question was the load on the NFS server. It's not significant. We already have a core node running because the Jupyter Hub process and the proxy process need to live there, and the NFS server just lives there on top. The quota enforcement itself is happening at the XFS layer, and that is not necessarily adding much of an observable overhead for us. We are monitoring the CPU and memory usage, and we're constantly tuning it. But it's not like, we've not had to switch to a higher instance size or anything like that since we added it. So the short answer is not a problem so far. One more, yeah.
Do you implement any sort of lifecycle enforcement to go in tandem with
The question is about lifecycle enforcement, and usually what that means is you tell people hey, if you don't log in for 6 months, we're going to throw it out or put it in object storage or something like that. We don't have anything like that yet. I do know that that's something a lot of people want. The problem is everyone wants something different, right? No two people want the same thing. One of the components here is a directory size exporter, Prometheus directory size exporter, and that does capture when was the last file last changed. So we do have the information that would allow us to implement lifecycle, hooks and stuff, but we currently don't have that as a part of this. Yes. Are we done? Okay. They aren't. The admin tells them, we would love to have a little Jupyter Lab status bar that tells you hey, this is your limit and this is how much you've used, but yeah.